Good afternoon, I'm Lawrence McNeil with Trihedral Engineering, and today we're going to do a quick walkthrough of setting up a Siemens S7 PLC in VTScada. So, first off, quick bit of agenda introduction. We're going to cover a bit of the background of the driver, the setup of the driver in VTScada, including the port tags, driver tags, I/O tags, some PLC setup requirements as well. There are a few specific settings that you'll need to make in some types of PLCs in order to get the S7 driver to function correctly. In addition to that, we'll also look at using some of our diagnostics tools, built-in tools within VTScada, as well as using Wireshark, followed by the Q&A session. So first off, a bit of background. Siemens S7 controllers all have integrated S7 communication services that use the S7 COM protocol. S7 COM protocol itself will function over industrial Ethernet, Profibus, Profinet, or MPI networks. VTScada uses the RFC 1006 variation, which is an ISO transport service on top of TCP. And what this is a standard TCP/IP network component that was put in place by the group that managed TCP. I'm at a loss for the name of them right now. That allows us to transport ISO protocol over top of TCP. The protocol, the Siemens protocol, is based on the ISO stack, so this allows it to be transported across TCP on most networks. So the sort of the layering of the whole thing is Ethernet carrying IP, which carries TCP, which carries ISO, which then in turn carries the actual S7 COM protocol itself. This is mostly just background information for those of you who may be interested in the little bits of trivia like this. And it really doesn't come into play much in setting up and implementing the driver. The protocol is actually fairly well supported in Wireshark. There is a full set of dissectors built into Wireshark for doing detailed analysis and debugging, if you should ever have to get down to that level. Okay, and again, for the trivia oriented, this is just a quick diagram showing which implementation of S7, the S7 protocol stack we're doing. It is in fact industrial Ethernet, IP, TCP, RFC 1006, with S7 protocol running on top of that. So that's really just a diagram showing you what the last slide showed you with text. So first thing is setting up in VTScada, and we'll do a quick little demonstration here of doing direct memory addressing inside the PLC itself. So the very first thing you're going to need to do to make this driver work is create a TCP/IP port tag. Currently, our driver only works on TCP/IP networks. We don't have support for any of the other communication interfaces other than TCP. The good news about that is that most S7 processors these days come with a built-in TCP/IP port. So we walk through this. What I have done is built a very small little Siemens S7 interface application in VTScada 12. So let's just start that up right now. And the first thing I need to do is create a TCP/IP port tag. My PLC that I have sitting on the floor here beside me is IP address 192.168.100.1, and all of these PLCs use port 102. So when we first create our TCP/IP port tag, we will want to point it to port 102 and the IP address of our PLC. Create a port, I'll call this PLC.port. Connection will be 192.168.100.1, TCP/IP port number 102. So that's the first step done. So once we create the TCP/IP port tag, the next thing we need to do is create a driver tag. And there are a lot of oddball looking options on the driver tag itself, and we'll walk through those very quickly, what it takes to set one up. For the most part, you can accept the default settings. So step number one, I want to add a child tag off of my TCP/IP port tag. and that will be of type driver. Scroll down, find the Siemens S7 PLC, and we're just going to call this one PLC port, PLC, let's call it CPU for lack of a better name. So some of the options. First off is the PLC type. The S7200 is an old oddball PLC, and it's considerably different in architecture than all of the other S7s. So it is a special case. So if you're using anything other than an S7200, just simply select the S7 other types. The next item is the priority, and this is really just the messaging priority. Either one of these seems to work just fine. The rack and the slot number, you'll have to reference for that back to your PLC software itself. So if we open up the S7 portal, I've got a PLC connected, and I've got a CPU, and I can have a look at it, step into the details, and from the TIA portal, it's telling me this CPU is rack 0, slot number 1. So when we set up our tag in VTScada, we simply set the, sorry, do a little screen switching here. Rack 0, slot 1. Some of the older PLCs, if you get interfacing with those, they have a CP module. We don't have a CP module in this case. So for the most part, that's all you would have to do, apply those settings. There are some additional settings over here which really get into the weeds of the details. But for now, we're not going to bother with those. We're just going to go with all the default settings for the PLC. Simply say OK to that. So we now have a port tag and a driver tag. Next step after that, we're going to add a couple of simple digital status tags. Read and write bit address M100.1 and M100.2. So new child. Now I did this demo originally in VTScada version 11. So I use digital status tags instead of the newer generic IO tag types. So bear with me while I use those. I'm going to go to digitals. Digital status, and we're going to call this tag, we'll call it M100.1 for lack of a better name. And we'll give it an address M100.1. That should be all we'll need to do. And give it a default 1-second scan rate. And you can see, as soon as I've created that tag, within a second, we now have a value on the tag of 0. And we can create another one if we want. Copy, paste, okay. We'll edit that tag, and we can change its IO address. So there we have 2 IO tags running directly from the PLC. Away we go, we're up and running. So create a port tag, create a driver tag, set a couple of settings based on your TIA portal, what TIA portal is telling you for configuration, and then add the IO tags. We can also add analog tags, and we're going to add a couple more to this one. I have new child, tag types, analog status. Yep, there it is. MW200, IO, MW200. MW, by the way, is memory word. So that's going to go directly to memory word 200. And again, we'll see that one should appear within a fairly short amount of time. We can add another analog status tag, new child, analog status, MD300. I'm naming the tags the same as their addressing, except this time around I'm going to do an MD, which is a memory double word, 300 with a slash float. So it will read a floating point value from that memory location. And give it time to scan. Of course, everything right now has a value of 0. We don't have much of a program running in the PLC at the moment, but we'll get to that in a minute. So that's the very basics. And if you ever need to see the details on the addressing for the Siemens, at any time you can step into the help system. The easiest way to get there is open up your driver tag and simply hit F1. That will take you directly to the online help for that, for the Siemens. And from there you can step into Siemens S7 driver IO addressing, where there's a long detailed description of the various addressing formats.
That's a pretty helpful tool. At any time you're stuck using VTScada, you can hit F1 and get context-sensitive help.
In particular with the drivers, exactly, Chris, that if from within any driver tag, hitting F1, it's just one more click from there to get you into the details of the IO addressing.
And since I've interrupted you, we've had a number of people arrive a little bit late, so I just wanted to welcome them and say that you haven't missed anything. You'll be sent a link to the recorded webinar, so you'll be able to watch that later. Thanks.
Okay, so that's the basics of getting it up and going. Now we'll take it a little bit further than that. Data types that we support. So we support quite a wide range of data types in the PLCs themselves. We have inputs, outputs, direct memory, special memory, variable storage, timers, counters, data blocks, peripheral input, peripheral output, analog input, analog output, local. So those are the data types we support. Again, as I mentioned, the VTScada manual on online help details the various IO addressing formats, how to set them up. I'll put a caveat on all this. The only one you really want to use are the data blocks. These are the powerful ones. For the most part, inputs and outputs are useful sometimes if you want to see your direct I/O, but it's the data blocks that are used. Especially if you're a Siemens PLC programmer, you'll understand why I'm saying this. The power of that of the S7 PLCs is in using the data blocks. Now, there's a couple of settings that we need to do in order to get our access directly to the data blocks. So first thing is we need to have the optimized data blocks function disabled. So to get to that, within your TIA portal software, you need to navigate to the program block that is that your data block belongs to. So program block, properties, attributes, and then you need to uncheck the checkbox that says optimize block access. And I can show you a quick walkthrough of that in TIA portal. So in my TIA portal, I have a PLC program. I have a program block in here, one called motor control. I go to properties, attributes, and here it is under optimize block access. What that allows us to do is to access directly by word byte bit number into that block. Okay, so what happens then is if you do that in your program block, any data blocks for instances of the program block will automatically have this turned off by default. Second thing you need to do is you need to disable optimized data access in the data blocks themselves. So back to my TIA portal example, I have a program block called motor control, and then I have, excuse me, 3 instances of that, M1, M2, and M3, which are data block 1, data block 2, and data block 3. So what we need to do with those is within TIA portal, navigate to data block, properties, attributes. So here we go, data block, right? It wants me to edit that. Properties, attributes, and you'll see here the optimized block access has been turned off. Slightly different. I did this screen capture in a different version of TIA portal than I'm currently running. I think I did this in 14. I'm running 15.1 now. And you want to just check that as we noted. So once those 2 features are done, you will be able to read the data directly out of the data blocks using the addressing scheme that VTScada implements. The only downside of this is when you're creating these data blocks, you have to individually disable them. It's a bit of a nuisance. All right, One last PLC setting you're going to have to make. This applies, I know, to the newer S7-1200 PLCs, could possibly apply to others as well, but we have to turn on a feature called Permit Access with Put Get Communication from Remote Partner. It's a bit of a mouthful, but again, from TIA portal, you navigate CPU, properties, protection and security, connection mechanisms, and you turn on that access. So that's over here on your CPU. Yep. Properties. I have to go back and figure out what it was. Properties, protection, and security. Connection mechanisms. And here it is turned on. This is in the PLC that I have. This is the program for the PLC that I'm going to be running this test against today. So a couple little things very Siemens specific there. All right, and check that, turn that on. Once we have that in place, then we can, then we have full access to the PLC with the S7 COM driver. Okay, so quick example, I have a motor control program block example. So what it is, I created a small little motor controller block in the PLC with a little bit of internal simulation just so we could show how we do an interface with it. And if we look here, we'll see the data types that are built into that. This is a screen capture from TIA portal showing the inputs to my data block and my internal inputs, outputs, and internal variables within it. And you'll notice that we have in here a column called offset. What that really is, that's the actual address of the data. And those addresses of those data addresses really come into play when we're creating the data block addresses in VTScada. I'll take you through that in just a second. So we have PLC block called motor control. There's 3 instances of it currently running in the PLC. Motor 1 is on DB1, motor 2 is on DB2, motor 3 is on DB3. Okay, we've already mentioned the offset column. So what we're going to do is create a context tag under M1 PLC driver tag. We're going to add the following tags. Start motor, address DB1, DBX60. So let's go back to our VTScada. New child, all tag types. Context, we're going to call this one M1. And we're going to do a new child, digital status. Start motor M1. And our address is db1.dbx6.0, I think I said it was. Yeah. And we want to enable the output on it because that's going to be my motor start. Let's just put these all up here. Create a couple more.
You've touched on this a number of times, and for those familiar with VTScada, it's kind of a standard issue, but would you just take a moment and talk about context tags in the context of what you're doing right now that you've got the browser open?
Okay, well, a context tag is generally just a placeholder. And you'll notice I've added a context tag called M1. So that's going to be all of my information about M1 is going to be stored within there. So all my tags for M1. So I've got start motor, M1 motor, and I'm just going to keep it. I'm going to add 2 more in there. Child, digital status. Oops, it's easier to copy and paste. I'm a bit lazy that way. Copy, paste as child. Motor M1 running. You'll notice it's got a .2 address on it. And new child. This time I want an analog status. I want motor 1 speed. And this one is db1 dot. Now, if you remember when we looked at the offset column on that previous screen, going back to our TIA portal, this is where I'm getting these actual numbers from. The X60, so that's bit 6, data byte, interpret as a bit, byte number 6, bit number 0, byte number 6, bit number 1, etc., etc. dbd8/float. So now we're going into data block 1. D8 is double word number 8, and we're going to interpret that as a floating point value. I'm going to put some proper scaling on here as well. Okay. So there you go. We've created a bunch of tags. I should be able to draw a start and a stop. Start button, stop button, a running indicator. And I want probably an indicator light for that. And I want to draw my motor speed. And I just got to check a couple of things here. It's just what values get written when we click on these buttons and whether we get a confirmation dialog or not. So what we should have now, start button, a stop button, an indicator light, and a speed. Now let's click the button and see what happens. So I heard a click and my motor speed got rolling. Looks as though I didn't quite get it right. And Chris, this is the whole advantage of practicing this well ahead of time.
It's a good time to point out that Lawrence has been flat out for the last couple of months, so he did manage to squeeze this in. There's a fair bit of preparation that goes into all of these webinars, so thanks, Lawrence, for taking that time to do that.
Even though it's not working, bear with me just a bit here.
It's a teaching opportunity. This is a teachable moment. Well, while Lawrence is working on that, I'll just take this sales and marketing moment to point out the fact that right now, again, for those of you new to VTScada, Lawrence is working with an online application. So as he configures this I/O and creates screens that display the values, he's actually working with a running SCADA application. You don't have to take the whole thing offline in order to add new tags and new objects. You can do that with live data in the live system. And you can validate those changes on the development license that you're doing the development on, and then when you're ready, you can roll those out through the network or through a series of change set files to the rest of your application. So this is it's better when you're working with live data, and you don't need to be blinded from your alarms coming in just to add a few more devices. End of sermon.
End of sermon, and I've corrected my mistakes here. Thanks for that. Thanks for giving me a couple of seconds there, Chris.
I can tap dance.
Anyway, I had a couple of addresses entered incorrectly. It's a problem with talking and working at the same time. Anyway, so we have the basic functionality working now. We have a stop button, the light goes off, speed goes to 0. Start button, the running indicator light comes on, the speed goes up to 41. So there's the very basics of a simple object control in a PLC done from individual tags. Now, as I mentioned earlier, the power of the Siemens PLC, and they were one of the early implementers of object-oriented technology at the PLC level, except they called them program blocks and data blocks, and realistically, it really was just an implementation of object-oriented programming in a PLC. The nice thing about them is that you can build one function block and use it over and over and over again. So add graphics and show control. Hey, we did that. So what we can do here, if I have now 3 motors to control, 4 motors, 10 motors, 100 motors, I really don't want to have to go through that exercise every time I want to create a motor. What I'd really like to be able to do is build a standard piece of VTScada configuration that we can reuse. And I've done just that. Make a tag type from M1. I've already made a tag type from it. I've called it an S7 motor. And what we can do, I'll show you what an S7 motor looks like, is again, off of my PLC, I'm going to do a new child from here. And let's go to my tag types and see if I can find it. I did this actually twice. I've forgotten that I did this a couple of months ago when I prepared this demonstration. So there's 2 of these that are all, there's an S7 1200 motor and an S7 motor. So the S7 motor is the one I did today. So we'll take a copy of that. We're going to call it the M1 motor. Other parameters, data block number. Now you notice this is a custom tag type within VTScada, and I'm going to give it the block number, the data block number in the PLC that we're using for this particular motor. In this case, we know that it's block number 1. Okay, great. So you'll notice now it's created an entire tag tree for me, M1 motor, HMI start, HMI stop, the running and the speed. So it's got everything on here that my original M1 had, but it was just a simple matter of creating one tag, pasting it in, and giving it the data block number. So when we look at these individual tags now, and the one thing that's changed in them, you notice that the address is showing up in blue, so that's using what's called a parameter expression. And what my parameter expression is, if you can read this, it says concatenate dB with the data block number, which is that value we entered in the S7 motor tag, along with everything else. So now all I have to do when I create a new motor, I don't have to create all the individual tags and punch in all those addresses. I just need to set up a template once and create as many of these as I want for as many motors as I happen to have. So if we take this one and then we draw it, and I've already created a widget that gathers together everything you saw me do for the first one, I'm going to do a draw. Yep, it's going to pop me into the studio. Sorry, hit draw on it. I've created a widget already. This motor start stop widget. It's slightly different, but almost it has all the same controls on it. So there, all of a sudden, I've got the same. Oop, I need to remove the. Need to remove the click, the trend. All right, let's try that again. So I can now start and stop that one motor. Do all the same controls I did from my individual ones, from the tag type, from the widget for the tag type. Well, all well and good, but where the power of this really starts to come into play is I know I have 3 motors in that PLC. They're all using the same program block, each of which, though, is using its own individual data block. So I can add more tags to this. New child, S7 motor. I'll call this one M2. Its data block number is 2. New child, S7 motor, M3. Data block number is 3. Jump back into the studio. I can do things like copy and paste that a couple of times. You'll notice they're all referencing M1 because they're all showing this exact same status and the same speed. Link that to a different tag. This time that one goes to M2. That one goes to M3. Close the studio. I now have control of M1, control of M2. You'll notice how it's independent of the others, and independent control of M3. So all of a sudden we've gone from long, slow, laborious process to configure multiple motors to a very, very fast, simple process to configure multiples, provided that they're programmed that way in the PLC. Okay. We already did all of this, replicate. Questions I had, the other one I was going to do was very quickly show you the communication diagnostics.
And just before you do, so far we don't have any questions in the queue. So anybody who's listening, now's the time to start punching in your questions in the GoToWebinar interface in the top right corner of your screen.
Okay, so some of the standard diagnostics tools that we have in the driver are the same diagnostics tools we have in almost all of our drivers, and these are things that I make a point to encourage people to, when they're building applications, create a system diagnostics display screen where you show the communication status and the show comm and show stats dialogues for all of your devices. So simplest way to do this, and this is the way I do it, I'm kind of old school because we did it this way in previous versions. I just find the tag, which in this case is our driver tag, right click, draw into diagnostics. So we can put a comm indicator, which is a nice little green box. Oh, where did they put that for me? We can put a show comms button, which shows the actual communication messages going on the wire. And we can put also a show stats button. We have a number of these different little widgets, but for the most part, these are the three that are really useful, particularly if you're calling tech support and you're saying, hey, this thing isn't quite working right. Show comms shows all the inbound and outbound messages going out across the TCP IP connection. This is the protocol level. It doesn't show you the TCP or the IP or the Ethernet portions of the messages, just the S7 protocol bytes. We also have a show stats dialog that tells you how many messages have gone, timestamps, all the rest of this statistical information. Or if you're having a problem, it'll tell you what the error code is. Numerically, it'll give you a description of that error. I also mentioned that we support, I shouldn't say that we support, that Wireshark supports this very well. And if we open up a quick Wireshark session, I just have to remember which Ethernet port we've got this on. It's this one, and I can filter to and here we see the S7 comm messages. You'll notice that Wireshark recognizes this as S7 comm protocol. So you can pick apart the messages and you can see these are the various addresses that we're reading. It even pulls them apart down to the individual address level. So some great diagnostics built in there.
While we're looking at Wireshark, it's probably a good time to brag a little bit. Our own Graham Blois, who is a core VTScada developer who works out of our Aberdeen office, is actually one of the core developers for Wireshark. I just had to throw that in there.
Inject that one, good. Okay, that's really the long and the short of how to set it up and make it work. A little bit of background on the protocol itself, some diagnostics tools and tricks, and I guess we'll open the floor for questions. Chris, do you have any?
No, we have one nice comment, which is great info. Thanks. Thanks to you, sir. Thanks to you, Lawrence. No other questions. I guess I have a question, which is we touched briefly on, you've been creating some analog and digital tags, and you mentioned in passing that in version 12 we have this new IO calculation tag. Without going too deeply into that, I guess, would you take a moment to sort of speak to how that might change this process?
Sure. Actually, it doesn't change the process at all. But what we've done is we've, and in fact, I can give you, I may not be the best person to demo this because I've had very limited access to it, but I'll take you very quickly through it.
And I should say this will be the topic of an upcoming webinar, so you don't have to carry all of that on your shoulders.
Okay, very quickly then. Everything, all the tag types you see me deal with here, we've got digital status tags and we've got analog status tags. And at this point in time, version 11 had somewhere in the order of 10 different tags that were used for various I/O tasks: analog in, analog out, digital in, digital out, analog status, digital status, analog control, digital control, the pump tag, and there was one other, I can't remember off the top of my head what it was. So what we've done in version 12 is reduced the variety of tags. We've come down to a single tag that does the functions of all of those, all rolled into a single I/O tag. Again, some of those were based on a lot of those other ones sort of go back in time in history and were developed for very specific reasons at very specific times in our product life cycle, which is some of them going back now 23, 24 years. So it was time for a refresh on that way of thinking for version 12. So we've created a simplified way of looking at it. So very quickly, I'm going to create an I/O tag. So off my CPU, new child, analogs, I/O and calculations. So there we go. We have the new tag type. We're going to call it test I/O for lack of a better name. We tell it the mode that the tag is going to operate. So it can operate as an analog, a discrete, which is really an enumerated, a digital, a 2-bit digital, a numeric calculation, a string calculation, or a string. So string, that was the one I missed on my previous list that rounded me up to 10. The string I/O tag. So it does all of these functions. So for an analog, we're going to do very simple, but the process is the same. We go to our driver and we'll give it a read address, and let's just give it, I'm going to cheat and pull an address out of one of those numbers I see jittering around up there, the M2 speed. There we go. Okay, so we just need to give it the basic information, and there's our test I/O tag, updating the same way as all our other ones are. I can draw that. And away we go.
Great.
That lines up with this one. So realistically, it is the same. It's all of our other tag types all rolled into one single general purpose tag.
And if I understand correctly, that also, an added advantage is that you can later change the type later on without losing your history, assuming that the data type is compatible.
Yes, that's correct. So for example, if you had a digital that eventually turned into an enumerated type, you had digital that was say a 0 or 1 that represented something on or off, and that got stretched in future to include on, off, auto, manual, open, close, several different states, right. Then that's exactly right. We would have all the original history for the 0, 1 for on, off, and then all of the newer values.